Machine learning is in the news a lot these days. Researchers are applying it to identify promising directions for drug development research, and companies are using it to derive market insights on consumers. But what is machine learning and how does it work? In the broadest terms, machine learning is a process in which algorithms can learn to interpret data by observing patterns in existing data and apply these insights to data it has never seen before. Machine learning depends on mathematical models, equations that try to represent the way something works by breaking it down to its most important components. One of the first steps towards the machine learning we know today occurred in the 18th century when astronomer Tobias Mayer made detailed observations of the moon. Using this data, he was able to create a very accurate model which would allow sailors to work out their longitude, a major unsolved problem at the time. Computers can do this on an enormous scale. Today, an astronomer could use machine learning on millions of observations from a telescope to identify patterns and novel findings with astonishing speed. Machine learning uses a wide array of techniques, but most have two components: prediction and fitting. Models are useful because they can make predictions about data. A common example is predicting the price of a house before it sells by using other information about the house. But other examples include predicting the stock market using recent trends or determining the best next move while playing a video game. In order for a model to get good at making predictions, it must see examples of the data and its correct labels. The process by which a model gets better at making predictions is called fitting. In the housing price example, this would involve showing the model several houses which have sold and their actual selling price. After fitting to this data, the model would be better at predicting the price of unsold houses. Consider how we would build a housing price prediction app, Bestimate. We could fit a model to public data about houses which have already sold and their actual selling price. Then users would use the app to predict the price of their house before selling based on the patterns which were learned. There are many types of machine learning models which can be used to make predictions. Two of the major types are called regression and classification. Regression models can predict a number, such as the price of a house. Classification models can predict which category something falls into. In the field of computer vision, some machine learning models are trained to identify specific objects in photos. For example, a classification model trained on the presence of cats could then be used to identify photos with cats in them. One technique which has become popular recently is called a neural network. While this type of machine learning technique was originally inspired by how the brain works, neural networks do not actually mimic a brain. Like the other machine learning models we have discussed, neural networks are just another way to make predictions from data. They are powerful because they can learn extremely complex rules for making predictions, whereas other types of models learn far simpler rules. While neural networks have outperformed most other models in many image and text related tasks, they can be notoriously finicky. They require tremendous amounts of expertise and large amounts of data to work well. This is one reason why user data is in such high demand by tech companies. These companies use the deluge of our consumer data in order to train their neural network models. You may also hear the term reinforcement learning. This is a type of machine learning that sets a goal, such as scoring points in a video game, and reinforces strategies that tend to reach that goal. Reinforcement learning works similarly to the way you might play a row of slot machines at a casino. These slot machines pay out at different rates, but you, as a gambler, do not know what they are. Your goal is to get as much money as possible. The first machine you start pays you $10 for every 100 pulls. That's not bad, but you want as much money as possible. What should you do? If you stay at the first machine, you might miss the machine next to it that could pay out more, or not at all. As a gambler, you have no way of knowing. This is known as the problem of exploitation versus exploration, and is common in reinforcement learning scenarios. Consider asking a machine learning algorithm to play Tetris. This activity is quite different from our previous examples of machine learning, because it involves a long series of actions leading to a high or low score at the end of each round, with no clear indication as to which move caused it to win or lose. A machine learning algorithm can be tasked with playing the game Tetris. Each round, it learns how to perform a bit better without the need for humans to be involved in telling the algorithm what is important. This is a particularly useful concept in robotics, in activities where you'd like the robot to learn to perform actions like walking on rocky terrain. One way online companies could use reinforcement learning could be to try to maximize profit. By making small adjustments to display different versions of their site to different users, they are able to get immediate feedback on what makes a user more likely to click on something or to buy it. For example, perhaps changing the color of an advertisement from green to blue gets more clicks. Then, one could try to find which of the different shades of blue is the most effective, letting user clicks on the ad shape the next user's experience on the page within fractions of a second. In this case, they are letting reinforcement learning algorithms explore different colors while still trying to maximize the number of clicks that they receive. Machine learning is an exciting way to analyze very large datasets and to observe subtle patterns for applications in scientific research, advertising, business management, and more. As a technique, it is sometimes misunderstood as being all powerful or magic because it is very complex. Neural networks, especially, are difficult to understand as a series of discrete steps. The better we understand machine learning from a technical perspective, the better equipped we are to anticipate what it is and is not capable of.